Recording. All right, so you can see on the left hand side there is a network panel where you will see your modes, your network, GSM. You can move it to somewhere. Can you guys stop your mic, please? Mute it. Recording. Okay. Okay. And the next panel is simulation control. From here, you can start, pause the recording, reload it, and the others are some uh, other panels we will discuss later. The bottom one is a timeline with the time which you will see the transmission of packets, and you will see those graphically on this bottom line. So let's start. Add modes, create modes. So you can see if you go to modes, add modes. These are the modes. Ethernet, some familiar names. You need to, we will work on sky modes. So we are going to get a mode. You can write description for that mode, whatever you want to write a description. You can write it here. And while we were in our lecture slide, we have seen that there are some already written codes inside this simulator. So we are going to browse and find out from where. If you go there, you will have Contiki, go to examples. And in example, you can go to IPv6, and then I'm going to find out RPL border router. So in RPL border router, you can see there is border router.c file. So take it, border router.c. So this is border router.c file. It is not compiled. So we need to compile it to get an object file. So this button, if you see, there's a button with the label compile. If you compile it, so you will see that there are some warnings. Just leave those warnings as it is. So we have compiled, and now we want to create that. How many modes do you need for the border of this type of modes? We need one border router. And positions, we want random position. It will place randomly on the network panel. Or you can write X, Y, and Z position uh, here. You can write it, but we are going to place it randomly. You can see we have placed it here. In the network panel, we have seen there is a circle where we have labeled 1. If you go to the view, In the view area, it says there are some features. We want address, IP address as well to be displayed, and we need radio traffic. Let's get some more modes. Add modes, create, sky modes, browse. So this time we will get IPv6, RPL, RPL UDP. Compile it. Yeah, so what is Mahin? Mahin, do you have any question? Oh, you randomly clicked, okay. Because I got that someone has raised hand and it was you. Okay, so we have compiled and let's create it. We need 5 modes. So we have 5 modes. And if you, just I'm showing you something. If you go to sky mode and browse, in RPL UDB folder, earlier we have only .c file, but you can see now there is the .sky file as well. So the .sky file is the object file. When you compile .c, it creates a .sky file. So next time whenever you use UDP client, you don't need to compile. You just take this one then and place it. And all right. So the one is our border router, and 2, 3, 4, 5, and 6 are randomly placed. We need radio traffics. Radio traffic means the arrow will shows that where is data is going from 1 to 2 or 2 to 3 or so when we run that simulation, you will see an arrow pointing towards where the data is uh, moving. We want a grid background, and we need a radio environment, UG UDGM radio environment. So you can see this is a radio environment. Let's go to zoom out. So you can see this is 1, 2, 4, 3, and 6. So you can see in the one there is 2 regions and discriminated with the colors. So the green region means the signal is very strong in this region. So when you place your your mute, your no mode into this circle, it means 1 and 2 have a this can communicate with each other without a signal loss because the signal strength is higher here. And in the gray area, the signal is weak. So let's place 4 as well, close to 1, and 5 with 2 and 3. and 6. So you can see 1 has two neighbors, 3 and 4, and 2 has two neighbors, 1 and 5. 5 has two neighbors, 2 and 3, and 3 has two neighbors, 5 and 6. So uh, this is a layout, and when you run that by using start, the output of mode will come here in this panel. So here you will see the time and the mode. If 2 and 1 is communicating, then we will have here that 2 is communicating with 1, and there will be a message. The message type, the message could be ICMPv6, or it would be beacon or non-beacon. So all sort of this that you have uh, gone through with previous slides. So let's run that and see. And I'm going to pause it. You will see here, just have a look about in the message section. And here you will see we have something written here at the bottom, FE8021. What is this? 444A210 and blah blah blah. What do you think is it? Is it the IPv6 address? And here in output panel, you can see the time, and this is the ID. When you click here, you will see the blinking of the circle. So rhymes at this time, when we started the simulation, the ID2 rhyme started with address this. This is the address, and then this is the MAC address, and during this time ID6 moved also starts powering and scanning around. Where, who is my neighbor, and so all sort of things are going on here. So you can go in detail here. Let's start that and see. So can you see the arrow coming from 2 to 5 and 5 to 3? I think. Let's see here. Look at this. ID5. ID5 is sending data to 1. Hello. ID5 is sending data to 1, and this is a packet of hello, and we have seen that the hello packet, we know that what is the hello packet, just sending to recognize that who is where and which path should we take. So everyone is introducing one another. So you can see ID4 is also sending data to 1, ID2 is also sending this and this. Let's pause that. So this is just an example on how to work and the introduction to how to create your simulation file, how to add objects, which panel does what. So I hope uh, by uh, at the end of this lecture, you have seen that how to use, how to open, how to create your, how to place the modes, how to compile them, how to run the simulation, and then later on we will use those to create some uh, specific networks, and we will then see the quality of network, their performances, and how DoDAG is created and how DoDAG works during the power on, after the power on, how they send beacon packets to one another, and how they become to sleep mode. All those things we will, inshallah, when we have time, we will see here and practice whatever we have learned. Any question?